All right, welcome everybody. My name is Brian McLogan, and I am coming to you live for some homework help. So in this live stream, what I'm going to do is cover some problems on the law of cosine. So this is in our chapter for applications of trigonometry, and previously we did the law of cosines in the last live stream. So now we're working on the law of cosines, because one of the important things was working with the law of sines is when we had a ratio within an oblique triangle. And the law of cosines is another method, technique we can use when we don't have that ratio. So what we're going to do is I have kind of two problems where we're just going to find the missing measures of the triangle. Then we'll go ahead and hit a word problem. Now, these problems do take a little bit longer, so that's why we're only covering 3 here on the front end. And then also what I'll do is then I'll go ahead and work on some multiple choice questions. And I am also going to be working with the TI calculator. So I'm not going to be presenting or showing you guys what I'm typing in the calculator, but I will try to write down as much as possible with the limited space that I do have, and then also kind of say exactly what I am typing in. So therefore, hopefully you guys can kind of follow with whatever type of calculator you have. You will at least need a scientific calculator to be doing this. And obviously in our class, we use a lot of the, TI 83, 84, 89 kind of family. And yeah, then that's really about it. So we'll just kind of go through there. Obviously, I asked some questions on Facebook as well. If you guys have any questions, maybe what I'll do is also check. So if you guys do have some questions in the meantime on the Facebook that you'd like to respond, I just put out a nice little chat and saying, hey, if you guys have any questions you'd like me to solve, I think, at least the Facebook, you guys can add in some different comments, like some pictures or whatever else. So if that maybe is more helpful for you, you guys can go and do that. Otherwise, for those of you guys that are on this live stream, you can always type in a question, and then after I'm done, I will try to get to them. So we got about 9:30. I'm going to try to get this stream done, roughly around like 40 minutes, and then try to see what else extra time that I have for you guys that I can answer any questions that you guys have regarding your own lessons that you guys are in, or own classes. So definitely see that Ray is in the house, and we have Axel. Good to see you. The Kitty Gamer is here, ready to go ahead and get started. So happy you guys could join for the stream, and we'll just kind of get started. Again, guys, if you have any questions of anything that I'm covering, at least on this topic, make sure you type it in there. What I'll try to do is at least scan back, depending on how many conversations you guys get between each other while we're doing some math. I'll try to see if I can scan, make sure if there's any questions or anything, but I'm going to pretty much focus on this first page and then check in with you guys from there. So, all right. This was quite a bit, so I'm going to go through this. Let me see here real quick. I don't think there's anything else. Yeah, I think it's just taken up. Okay. All right, and Riley, hola, Jason, Zabs, good to see you guys for joining in. That one nugget there, happy to be able to help you out. Awesome. All right, guys, let's go ahead and get started. So the first one is find all the missing measures. So I'm going to kind of treat this as far as what I would be teaching my students, because they have a quiz next class period and the class period after that. So therefore, preparing this like a quiz, if they had a problem like this, one of the things I'm looking for is creating a triangle. So let's just go ahead and represent this information here as a triangle. So just going to go ahead and label things. So we'll call that A. Now, 59 degrees and 50 minutes. One thing we're going to need to do is, again, convert that to decimal system. So I say 59 degrees, and that's going to be plus 50 over 60. So I'm just going to get to figure out what 50 over 60 is. So 50 divided by 60, and that's going to be 0.8333. And I don't really like that, so I'm going to add that to 59. So I have 59.8333. And what I'm going to do is I'm just going to store that as alpha A. So I'm going to hit store, and then I'm going to store that as A. So we are going to, so that's going to be stored as my alpha A. Okay, and I just like to put brackets around that. That just reminds me that that is going to be a stored answer. So I'll still write it in here, 59 degrees and 10 minutes. And then we have, let's just go ahead and label b up here. So therefore b is equal to 20. And then let's see here, c is over here, and that's a lowercase c equals 30. I don't want that. So the important thing is notice that b and c are going to be lengths, right? They're not angles. There's no degrees there. So oh yeah, I was thinking like law of sines for a second. That's how crazy it is. Of course, we're in the law of cosines, right? So what we recognize here is the information that we have is kind of like a side angle side. So therefore, we're going to be solving using the law of cosine. So we have a couple formulas for the law of cosines, and basically what I gave the students today in class was, let's see, the one we're going to want to use here is going to be for the a squared. So let's see, it's going to be a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of a. And you want to use this formula when you're looking to solve for a side length, which in this case we're going to. So we only have one angle here, which in this case happens to be a, nice, convenient. And therefore we can go ahead and figure out what our side length a is. So this one works out. Now, again, if you had another angle, what I've told my students is, again, just rearrange the variable, like rearrange these however you need to, right? I mean, we could write these equations for a squared, b squared, as well as c squared. Just move around the variables. All right, so let's go ahead and plug this in, though. So I'm going to get a squared is going to equal b squared, which is 20 squared plus 30 squared minus, I'm going to zoom in. 2 times 20 times 30, and then times. Now, rather than writing in this 59, I saved that, right? I showed what this a is. So I'm just going to type that in, because when I type in my calculator, I'm going to type in the stored answer a, right? So we can just type this into our calculator. Typically when doing this, though, I like to provide as many parentheses as possible. So, I even provide an extra set of parentheses when I'm typing this in. I even provide parentheses over here just to make sure. Like, I like to provide as many parentheses as possible. So when I'm typing this in here, so I have 20 squared plus 30 squared minus, open parenthesis, 2 times 20 times 30 times the cosine of my a value, which is 59.833. Close that parenthesis, and then I close that other parenthesis. And therefore, I get a squared is 696.97. But again, that's what a squared is equal to, right? So therefore, I'm not even going to write that in. I'm just going to take the square root of that last answer. If you don't have the last answer, you could just retype it back in. And I get 26.4. And I tell my students to round to the nearest thousandth for any kind of side length. Since that's 26.400, then we'll just write that as 26.4. All right, so since this is now a found answer, I guess I'll write this as, a is equal to 26.4. Okay, so we applied the law of cosines, right? Because that's the only thing we could do. We couldn't apply the law of sines. Now, here comes the next test. We could either use the law of cosines to find one of these other missing angles, or we could use the law of sines. So, it kind of comes in debate. The easy thing to do, I think, to not make a mistake would just to always stick with the law of cosines. Now, the law of cosines formula, which I hope I wrote down again. I guess I didn't, but I'll rewrite it from here. So just so we have this, so we can reference this later. So the law of cosines, if we're trying to find an angle, basically if I just wanted to solve for a, is basically just solve for cosine of a. So that's going to be b squared plus c squared minus a squared. Oh, sorry. That's c squared, a squared. Let me type that out, because then you're dividing by a negative. So if you're solving for a, that's going to be, let's see, c squared plus b squared, minus a squared, and then divided by 2 times b times c. There you go. Okay, that would make that negative. Okay, that's right. But that looks bad with that 2, so let's fix that. Okay, so if you were to just solve for cosine of A in this equation, you would get that. All right. Now, you could use this formula. Again, we already have A, so we wouldn't use this formula. We would just rearrange them so we could solve for B, or we could solve for C. Now, you can do that, and that's probably the best way, especially if you think you might make mistakes. I prefer using the law of sines when possible. But you got to be careful with the law of sines, and we talked about this in class, and it's kind of hard to really go into unless I'm going to get deep on this topic, which I don't want to for a homework review. But the main important thing is when you have a problem, when you have a side angle side, and you're going to go to law of sines, you have to use the law of sines for the smaller of the two angles. So we have two open angles, B and C. What we're going to want to do is use only the law of sines for the smaller of the two angles, because basically, if you remember, when you're doing sine inverse, that always gives you the acute angle. It doesn't give you the obtuse angle. And right now, we don't know if B or C could be obtuse. Like right now, B and C, one of them could be obtuse. However, the smaller of the two angles is definitely not obtuse, because if the smaller one's obtuse and then the other one is also obtuse, that wouldn't make sense, right? So the smaller of the angle cannot be obtuse. So therefore, that is what we're going to solve for. Now, again, using the law of sines, I'm going to be looking for B. So I'll actually do this in purple again. So therefore, we'll say sine of B all over 20 is equal to, let's see here. Oh, did I not store? Ooh. So here's my new angle A, right? Now, I'm going to store this. So this kind of can get a little confusing here. Let's store this as E. Okay, so I'm going to store that. Actually, let's store this as D, because I don't want to get this confused with the A, B, and C of the angles. So I'm going to store this as D. All right. So anyways, we have sine of B over 20 is equal to the sine of A, which we've already stored. That's why I can't use that as A, all over D, which is going to also be stored, which is really the lowercase a. So now, if I want to solve for B, hopefully you know you're just going to multiply by 20. So therefore, I'm going to, let's see, it's going to be 20 times the sine of A, which is 59.83. And then I'm going to divide that by my new saved answer, D, which is 26.4. And then obviously there's more decimals. Okay, and now I need to take the sine inverse of that, because again, what I just did, I just multiplied by 20. Now we got to take the sine inverse of that. So I'm just going to do the sine inverse of that last answer. And that gives me 41, which is or 40.9. So B is going to be a 40.9 degrees. And then what I can do is, if you want to go ahead and convert this over to minutes, we could go ahead and do that. I'm just going to leave everything in our decimal form, because one that we didn't really cover as far as converting from degrees to minutes, but typically that would be a ideal message, would be basically to take the decimal version of that and then multiply by the 60 to be able to get a number of degrees. But for this case, I'm just going to leave it in the decimal form. And then, obviously, what we have here is now to go ahead and solve for C. So angle C is basically 180 degrees, because remember, all the angles in a triangle add up to 180, right? So that's basically going to be, now let's store this as angle B. Okay, so that's going to be 180 minus stored angle A minus stored angle B. Right, so we store this angle, and let's show how this got stored as D as well. Okay, so now just go ahead and solve these two. We get C is equal to 180 minus alpha A minus alpha B. And that gives me 79.24, which again, not just to leave in decimal form, as 79.24. I don't know what I was writing. I guess round to the nearest hundredth, so that'd be 792.4. Yeah, so I'll round that. I'll leave. Let's see here. Hold on a second. What am I want to round these to? So if that, see, that's not really being rounded, so that's why it kind of gets a little tough in this case. So let's go ahead and round these to the nearest. This would be 2.5. And B, remember our B would be 9.17 or 9.12. So that's why it's always tough to, it'd be best to go ahead and convert these back into degrees, but for the sake of just go ahead and looking into your degrees, I'm just going to leave it as that, as a degree, and just leave it to the round 100 because I did not clarify how I was going to actually round these. So we'll just kind of leave it in that format for now. Obviously, again, you could just multiply the 0.25 times 60, and then that would give you the number of minutes from there. Obviously, the whole angle would be the best idea. All right, so now let's go ahead and get into the next triangle, which is a side-side-side triangle. And so in this one, again, the first thing we want to do, guys, is just draw the triangle. So again, you can draw the triangle any way you want to. So we have A, B, and C. So across there, A is equal to 16. In this case, B is equal to 24. And that's not B equals 24. B equals 24 across from angle B. So B equals 24. And then this one would be C is equal to 13. Okay, so we have no angles, right? So we can't use the law of sines. We're going to have to use the law of cosines. Now, we got to find all of these angles. Now, really, we only need to find 2 of the angles because then once we know 2 of the angles, we can just subtract them from 180 to find the third angle, right? So if you are comfortable with using the law of cosines, you can just use the law of cosines to find angle A, rearrange the variables, and then go ahead and use it for cosine of B or cosine of C to find those remaining variables. So that's the easy and the simple way to go about it. If you prefer using the law of sines, then again, to avoid having an obtuse angle, what we're going to want to do is find the largest angle first. Because if we find the largest angle using the law of cosines, we know when we use the law of sines for the other 2 angles, we're not going to have to worry about having an obtuse angle. So you can see here that the largest angle is going to be B. So therefore, instead of writing the cosine of A, I'm going to want to write this for the cosine of B. There you go. So let's go ahead and rearrange this for cosine of B. So this would be cosine of B, that's a horrible B, is going to be equal to, so basically wherever there was an A, I'm just going to replace it with a B. Wherever there's a B, I'm going to replace it with an A. So this would be a C squared plus A squared minus B squared all over 2 times A times C. All right, so now when I actually would plug in the real numbers here, cosine of B is equal to, I'm going to use my parentheses, so C, we're going to have 13 squared plus 16 squared minus 24 squared all over 2 times A, which is 16, and then times C, which is 13. Okay, so let's just go ahead and type this in just to make sure that we got it correct. I did kind of work these out just to make sure that I would have something, or if I'd know if I typed something in wrong, so I could go and see, because I didn't really trust my skills with a calculator that I don't use on a normal basis. So, but I always like to type everything in one by one. Rather than like multiplying everything in together, just because it's easier for me to kind of see, or one, follow the order of operations, and then also just to kind of see if I make a mistake. So I'm getting the cosine of B is equal to negative 0.36 ... other decimals. So therefore, to find B, I'm going to take the cosine inverse of that last answer, and I get 111.28 degrees. So I can say B is equal to 111.28. Now, to be a little consistent with problem, I'm going to kind of give you guys a little bit of an idea. The reason why I wanted to include one of these problems was just because we have these, come up in the word problems, but that would really be just to be able to solve like for that mini side. I didn't really want to find the all the missing angles in terms of degrees because that's not something we covered in our class. So typically what I've told my students and what's going to happen when they take their quiz is I'll say just round to the nearest whole digit for degrees. So this would be 111 degrees. We'll just round that to 111. All right, so now I have 111 degrees. However, again, if I'm going to be using this, which I'm going to be, I don't want to use the rounded answer. So I'm going to have to store this as my alpha b. Okay, so don't use your rounded answer. Even though you're rounding it, I just wrote this to the nearest, thousandth here. Still, even if you're going to write your answer as 111, you still want to make sure you have the full answer, not just this rounded answer. So now that I found the largest angle, I know my other two angles are not going to be, are not going to be obtuse. So now I can just use the law of sines. I need to find another angle. You can do A or C. It doesn't really matter. Let's just find A. So let's do sine of A. Or what did I do actually in this? Yeah, I solved for A. Cool. So 16 is equal to the sine of stored answer B over 111. So therefore A is basically going to be 16 times the sine of stored answer B divided by 16 times the sine of stored answer B, there you go, divided by 111. And then now I do the sine inverse of that answer, and I get 7, which is not what I got before. That's something crazy. So what the heck did I do? Let's just check that again. So I want to check things. So B is 111.28. Good. All right. So let's do sine of B. Okay, and that's going to be times 16. Oh, I'm an idiot. I see what I did. You're not dividing it. Sine of B is over 24. Crazy. Don't even know where that came from. That's 24. All right, so then divide that by 24. And now I take the sine inverse of that answer. See, and this is why I work out the problem before, so therefore I realize that that one doesn't make sense. So I get 38.404 as a rounded answer to the thousandth. However, I'm just going to, round that to 38 degrees. Now again, I'm still going to store this though. So I'm going to store this as alpha A. So now when I want to figure out C, what I'm going to do is this has been stored, right? I've stored this answer. So then I want to find C. I'm going to do 180 degrees minus my stored answer B minus my stored answer A. Now, this really doesn't matter as much because we're dealing with degrees, which we're going to round to the nearest whole anyways. So you don't really, that's not really that big of a deal to do this. I'm just trying to get people in a good mind of not using rounded answers, making sure that they're using these stored answers. But in reality, since we're going to round again to the nearest whole, there's not going to be much here, and again we get 30.3, which rounds to 30 degrees. So C is going to equal, let's just do a rounded answer, 30 degrees. So there are your three answers, and then we are given all the side lengths. So that's basically kind of what we do. So again, remember guys, when you have a side angle side, you're going to want to use the law of cosines or a side, side, side. Okay, so law of, just to kind of review, you can always use the law of cosines, which is awesome. You can just use these two formulas to find all your missing sides. Or if you're going to use the law of sines with the law of cosines, when you have a side angle side, make sure you look for the missing angle that is the smallest. And then where you're doing side, 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 make sure you solve for the angle that is the largest first, and then you guys are free to use the law of sines. And if anything I said doesn't make sense to that, just continue using the law of cosines and you won't go wrong. All right, so for next one, question number 2, word problem. Hey, got a Josh, thank you. I just saw that I got a little super chat. That's awesome, man. I appreciate that. I'm the same country as this guy, but for some reason I'm following him. Well, I'm very happy to help you, man. I really do appreciate the nice little super chat, and that is awesome. And I do apologize for a lot of you guys I am seeing some problems that are coming in, so that's awesome. I'll try to do my best to get to your questions here. I'm just going to run through these word problems, and then we'll hopefully knock out the rest of those multiple choice here rather quickly. So, but then again, I do appreciate, Josh, the help and support. And then for all of you guys also that have joined into the chat so far, I'll try to do some shout outs here when I take a nice little break. All right, here we go. So 2 planes fly an airport from different runways at the same time. The first plane leaves at a bearing of north 66 degrees west, traveling 350 miles per hour, and the second plane leaves at a bearing of south 27 degrees west, traveling at 325 miles per hour. After 2 hours, how far apart will the 2 planes be? All right, so for word problems, we spent a lot of time with word problems the first day of this chapter. And the main thing I told students to do was first just draw the scenario. So we're going to have a little fun doing our northeast, southwest. Okay, so here's north, east, south, west. Okay, so let's do the first plane. Is north 66 degrees west. So that's going to look something like that. So there's your angle, 66 degrees. All right. The second plane, so here's the airport, by the way. The second plane is leaving at south 27 degrees west. And I don't know why that's going bigger. I'm just going to, which one travels? This one's going 350 miles per hour. This one's going a little bit slower. So this one will be a little bit shorter. Okay. So that one is at 27 degrees, right? So south, 27 degrees west. All right. Now, the question is, after 2 hours, like how far will they be? Well, so again, we're basically looking for this distance here. Okay. And the other thing is, now do we have these distances? Like how far did this plane travel? Well, it's traveling 350 miles per hour. And if it traveled 350 miles per hour for 2 hours, that means it has traveled 700 miles. And this plane obviously is traveling 325 miles per hour. And if it traveled for 2 hours, then it has traveled 350 miles. Okay. And then let's just call the distance between them D. So I'll say D equals the distance between the planes, since that was not provided to us what our variables should be. So therefore, that is what we're going to solve for. Actually, you know what? That is bad. Let's keep this consistent with our variables, and let's make this a lowercase a. So therefore, we have an uppercase A, and then we have a lowercase a. Now, is that necessary? No. You can make the variables anything you want to. But to just kind of keep things consistent with the A's and, the angles and the side lengths, I think this makes sense. All right. The other thing we can also do is one of the big things about bearings is using complementary and supplementary angles. So we know that if from here to here is 66 degrees, then we also know that from here to here is 28 degrees, right? Because these two angles have to add up to 90 degrees. If this is 27 degrees, then again, we know that this is going to be 63 degrees. That's not 28 degrees. What was I saying? That was 24 degrees. What the heck was I doing? Okay, so let's rewrite that. No. That's going to be 24 degrees. All right, so there's the information. I've now taken all this piece of information, and now the next step I want to do is create a triangle from it. So I'm just going to redraw the triangle as kind of like best I can. And because what I want to do is determine like how should I solve this, right? It doesn't say like use the law of sines, use the law of cosines. It just says find this angle measurement, right? So we have 24 plus 63, right? Obviously those added up are going to give you that angle, which is going to be 87 degrees. And then here we know is 700 miles. And then here is 350 miles. So again, the question is, how far are they going to be apart? Well, you notice this is a side angle side, we're looking for A. Let's just maybe call this B here and this one C. So therefore we can kind of like label these in there, because now I can just use my law of cosines problem. I have angle A. I need to solve this A, so I can use the formula A squared equals C squared plus B squared minus 2 times C times B times the cosine of A. And obviously I think those variables are arranged differently than what I had written up there. But again, it doesn't matter how you order them when you're adding and subtracting, or adding or multiplying. So remember, guys, these are the lowercase c and b. So these are the side lengths. So now let's just plug them in. So A squared equals 700. Now I'm not going to include the units just to save me some writing. 350 minus 2 times 700. Oh, please tell me I have more room. Okay. 700 times 350 times the cosine of 87. All right, so when I go ahead and type in this lovely useful of information, let's do this. 700 squared plus 350. Every single time in class I did the same thing. Square that. I don't know why I don't write that. 350 squared. And then minus, I just like to add in another parenthesis. I don't even know if this makes difference. I don't think it does, but I am just like, I guess that's like a little bit of my type A that I like to do. 2 times 700 times 350 times the cosine of 87. And then I double close parentheses, and I get a really, really big number. And then I'm going to take the square root of that number rather than trying to say it. Let's see actually what this is. That's going to be 3. So 500, no, 1, 2, 3. Yeah, 586,855.3814. But again, that's for A squared. So if I take the square root of that answer, I'm not getting the same answer that I got before. Crap. Oh, I'm an idiot. I didn't double that. It's for 2 hours, so that's 650. All right, I'm not sure what I said. But yeah, that's 650. I'm so glad I worked these out before, because I just would have made that mistake. So that is definitely a 650. All right, so now let's retype everything back in again. Great. This is turning out to be awesome. 650 squared, and then minus 2 times 700 times 650 times the cosine of 87. All right, now I got 864,874. Take the square root of that answer, and I get 900. Crap, I'm not getting the same answer again either. Now I'm getting a different answer each and every time. So now the question is, well, which one did I get? Which one is right? There's the question. So A equals 929, but that's not the same one I got before. So I'm going to type this in one more time. Man, I kind of wish I had my TI calculator right now. It'd be a little bit easier to see what I'm doing, see what I'm typing in. So 700 squared plus 650 squared. Okay, and then we're just going to subtract that from the quantity 2 times 700 times 650 times the cosine of 87, and then square root that answer. All right, so I'm getting 929, and that makes sense. I'm not sure where the 895 came from, but this distance makes sense. So I'm just going to run with this. This is 2 times in a row. I've got it. So unless I'm making the same mistake. However, if there's anybody out here that's got the same answer, or that got this 895 mystery number I got, I don't know. We were watching TV and I kind of ran, so I wasn't really watching fully what I was doing, but that was just another number that I came up with, and I'm not sure what I might have typed in wrong. So either way, that's I believe I'm just going to roll with this number because it sounds right. It works. Like obviously that would be the longest. That's going to be a longer side than those two sides. So it looks like it's going to work. And I'm typing it in everything as I should, so I'm not seeing a mistake there. So that will be it for at least the free response. So, the same kind of thing. The word problem is actually not too bad because typically word problems you have to do less work, right? For here, we had to do like multiple steps. And even for the, multiple choice you guys are going to see here, we're going to have to do multiple steps. But either way, we'll kind of come back to doing those multiple choice. But I just want to check in with you guys. Just got to see if there's anybody else having to there or kind of maybe see some questions I got. So Damon says I got 103% because of you. Well, I am so happy for you. Well, I hope you do go to Harvard. Go and apply, man. That's awesome. Money Monster says, I love you. I'll give you money, I promise. Well, hey, man, I'm not here for the money for the thing. It's I'm just happy to be able to help you guys out with your math. And that's, I do appreciate you guys showing up for the stream and showing your appreciation by your thanks. It does mean a lot. Obviously, always supporting me on YouTube. Super chats are great. Or if you guys are interested in, these documents that I provide using the YouTube membership, that's another way to support support me on my channel, just not by watching my videos and stuff like that. But I appreciate everything for you guys. It always helps, especially the young children of my life that take up so much of my time. My own children, not my school children. But school children, they take up a lot of time. But we're almost getting to the end of the year, which is like the cool, crazy thing. It's like you can see we're like in that slow decline now. Like we only got a couple more lessons left, and then that's gonna be in the year. So don't leave yet. I still got the multiple choice I want to go through. Just want to see if there's any questions. I always like to get off topic, and yeah, it's kind of crazy. So that's what I'm going to look into. I think once I'm done teaching, I'm just going to kind of continue like doing live streams where just doing like an open live stream just to be able to help answer some questions. Cause I kind of like just going live and hanging out and talking with you guys. Obviously these I do, primarily for my students so they can check their work and, and stuff like that. But, it's also great to kind of interact with you guys. So I guess what I'm going to do here is I'm going to finish up the multiple choice, and then I will go ahead and see what homework questions or what other problems you guys can have, because it's 10:07. All right, so I got about 20 minutes, so I'm kind of running a little bit behind, so let's try to knock this stuff out. All right, solve the triangle. Great. It's a side, 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 so I know I'm going to use I'm going to want to side, 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 so therefore I know I'm going to want to use the law of cosines, and I'm going to want to find the largest angle, so that's going to be angle A, right, because that's going to be opposite of the largest side. The largest angle will be opposite of largest side. So if I want to find cosine of A, then I would just do, I'll type that in so you guys can see what I'm typing in. So cosine of A is basically following that formula that I have, and actually I don't even remember, where's question number one? There's question number one. So that's going to be b squared plus c squared minus a squared divided by 2 times b times c. Okay, so let's just type that in. So a is equal to cosine inverse of 16 squared plus 11 squared minus 19 squared all over 2 times 16 times c, which is 11. All right, so let's go and figure this one out. Actually, you know what? Let's save some time. I already did this. So when you do this, I got to type this in my calculator anyway, so I got to store this. So let's just do it. So 16 squared plus 11 squared plus, minus, parentheses, 19 squared, and then divided by 2 times 16 times 11. Okay, so, and then I'm getting 0.045, so then I do the cosine inverse of that answer, and I got A, which is 87. Okay, I didn't write that down, so I'm going to store this as alpha A. Cool, so A is 87, so therefore it's not C, and it's not D. All right, so now I'm just going to solve for B. I guess that's the next one on the list, right? So then I'll just do sine of stored answer A let's just do A equals, 87.4. And then divide that by 19 is equal to, let's do B. You could do it for C either. So sine of B over 16. Okay, so therefore sine of B, multiply this by 16, take the sine inverse, and then I got 57.4 for B. So therefore that gives me answer B. So when you solve for B, you get B equals 57.3, right? It was actually 27 when you round it, but so there you go. So I'll try to save myself some time. Hopefully you guys, at this point, you guys can kind of solve from there. The next one is, we notice this is going to be a side angle side. So if we want to solve, the first thing to make sense to solve would be our side length, which would be B. So therefore I can write this as B squared. Now again, here you don't recognize anything, right? So it's kind of confusing, I think, for some people to be like, well, I have this alpha and beta and all these other, kind of stuff going. So notice here's the alpha, and therefore this is A, right? So this is your gamma, and they already have 6 here, so that's not a part of it. But then this is your B. Okay, so they have B in there in that case. All right, so what we can do here is let's go ahead and figure out what B squared is. So B squared is going to be the two side lengths, 3 squared plus 6 squared minus 2 times 3 times 6 times the cosine of 25 degrees. And I guess I'll just have to type this in because I'm going to want to store this. All right, so therefore it's going to be 9 plus 36 minus, parentheses, 2 times 3 times 6 times the cosine of 25. And then I get 12.37, so that's B squared equals 12.37. So take the square root of that answer, and I get 3.51. Is that an answer or 3.517? So therefore B is either going to be C or D. So those are not my two answers. And now let's just go ahead and solve for A, right? I mean, let's figure out what A is, or was that supposed to be represented as alpha? I think that's supposed to be represented as alpha, not A. So maybe I typed that in wrong. My bad. Yeah, those should be alpha, not A. All right, so then let's go ahead and solve for A. So let's store this. This is what, B. So let's store this as B. All right, so now if I just want to solve for, I guess that's a good point here. You know what? So in this case, that's actually a good question. I didn't check this before. So if you remember, I was talking about, actually, no, okay, we can find that. Yeah, let's go ahead and find alpha, because obviously alpha is going to be smaller than, alpha has to be smaller than gamma, right? Because the opposing side is 3 and this opposing side is 6. So actually, you know what? I'm not even going to solve this. Here's your two answers, right? We know B and B. We know that alpha has to be smaller than gamma, because look at the opposing side of alpha is 3. The opposing side of gamma is 6. So you could do the law of sines, and actually that's what I did. I did the sine of 25 degrees over this stored answer B is equal to, the sine of alpha over 3. But that's a waste of time, guys. You know that alpha has to be smaller than gamma. So therefore the answer is C, which I ended up getting anyways when doing the work. But it's a multiple choice, so as long as I showed my work, I'm good to go. All right, for the area of the triangle, we're going to use Heron's formula. Notice that we don't have any angle, so we could create a right triangle, find an angle, and then use our other formula that we talked about. Because remember, like a triangle, 1/2 base times height. But to find the height, we need to use an angle. And when we don't have an angle, the easiest thing to use would be Heron's formula. Now, the important thing about Heron's formula is identifying C, which is basically the sum of the angles divided by 2. So in this case, when you do that, you get 21.15. All right. Now, Heron's formula is basically, so the area is equal to S times S minus A times S minus B times S minus C. Now, since this is really just a plug and chug type of problem, I'm not going to go through this and retype it back in, because when I did this, I ended up getting, actually I didn't write down my answer. It was like 84 rounded or something like that. But anyways, it gets you 85 is the correct answer. Or at least the answer I got, unless I made some mistake. All right, last one. Another word problem that now we got to like figure out what the heck is going on. So it says 2 points are on opposite sides of a building. So let's draw a building. Now, it looks like this one maybe might make sense if I'm looking, let's see from like bird's eye view. So let's say here's the building. Okay, so let's call this A. And here's B. So 2 corners of a building. And are on opposite sides of the building, and the surveyor selects a third point, C, to place a transit. Point C is 54 feet from point A, so let's say here's 54, and 69 feet from point B. The angle between them is 53 degrees. All right, and how far apart are points A and B? Well, again, guys, you can see that this is a very common difference. We're basically looking for this side length C. So, again, to use our formula, C squared is just going to equal to A squared plus B squared minus 2 times A times B times the cosine of 53 degrees. And again, to save myself a little time, I did this, I plugged it in, and I got 56.5. So, I mean, I think you guys can hopefully, or at this point, you know, we can move a little bit quicker on this since I've done multiple of these problems. You guys can plug in the, actually, you know, I'll just type in what they are. I'm not going to type them into my calculator, but it'd be 69 squared plus 54 squared, just to make sure you guys know exactly, you know, what I typed in, and therefore you can get the same answer. All right, so there you go, ladies and gentlemen. That is the homework for the law of cosines. Now what I'll do is, let's see, I don't got much time, but I'll just kind of see if there's any homework questions maybe I can address from you guys. I'm not sure how much you guys have been talking, how much I got to go through, but I'll try to check in with you guys. Max, the King, Kyle, the F-Bug Gamer, Supreme, Destiny, how is it 350 miles? Yes. Thank you, Destiny. I know it's a little late after you commented, but thank you so much for noticing that, because I was like, what is going on? I'm getting that problem wrong. So thank you so much for that. Rather says teach AP Calc next year. I'm hoping I'll teach AP Calc. We'll see. I would love to kind of add on to this pre-calculus curriculum and kind of do the same thing for calculus, at least just getting some more curriculum out there for you guys. So, found your Charmador says, I found your channel recently. I'm hoping to pass college calculus with applications. You got this. You can definitely do that. You know, not only just are my videos, but there's a ton of content out there that's available for you. Just keep on working hard. Show says, hi, for whenever you're finished here, how can I find the area of a polygon when I'm only given the apothem? I do not remember. I mean, obviously, it's been a while since I touched geometry, so I kind of forgot that the definition or the formula with the apothem. But I'd say you're probably I'm assuming you probably have like a regular polygon. And so therefore you at least know that all the side lengths are going to be equal. And I just don't, I'm sorry, it's been so long since I taught geometry, so I just don't recall exactly what would be the best thing to do from that. But I would assume that probably something saying that's a regular, and obviously that's what you're going to want to use, whatever, with that formula, and kind of use some of that understanding. But sorry, I don't recall it back from the end. All right, let's see. Is there any other questions? Let's see here. Any? Y equals 5, exponent of 5. Farm, don't even know what to graph that. Crazy. I'm really glad YouTube added in the automatic message held for review. If you guys are seeing some of the comments I'm seeing, you probably wouldn't be surprised, but you would probably see. So yeah, YouTube at least filters out some comments, which is kind of good. So that's interesting, because it used to not do, and it was kind of a little like embarrassing to like get online and see what some people were saying, and then you're close to like you're trying to talk to people, and you're like, oh wow, they just say whatever you want to say. But now some things that are like, sensitive, whatever else they, or just outright mean to say, they a lot of times will flag them. All right. Well, I guess nobody has. Oh, there's a good x squared. All right. So we got 1. So solve. Ow. So we have x to the 4th minus 7x squared minus 12. All right. So I'm assuming that's going to be equal to 0, since you need to be solving something. So that comes from Icy. So I will do that for you. And then I think there was one more, which was like FOIL. So let's go ahead and do that. And this one came before my live stream. That's going to be b minus 2c times b plus 2c. All right. Let's see if there's anything else that I'm thinking. Intercepts. Find the intercepts. All right, I can do that. So intercepts. And this one comes from Sizzy La Loca. So y minus 4 equals 7 times x minus 6. All right. So that's to find the intercepts. And if I want to start with said, Mr. McLogan, I'd like to thank you for your help, Mr. My Algebra 2 teacher is already teaching us Calc 1. If it weren't for your videos, I'd be failing terribly. Well, I'm so sorry to hear having some issues with that, but I am very happy that my videos, you can kind of like, I taught Algebra 2 for many, many years, so hopefully you can kind of just follow along, with a lot of the content that I have up there. And I know it's kind of a tough thing. A lot of teachers are all over the place and speed up. I mean, a lot of kids say that about my own students, say that about my own, pacing, that we can move fast, and everything like that. So, I totally understand it. I think the main thing is just, doing what you can and just keep on, try to stay with the content and just keep on working hard and obviously seeking out resources and answers to help you out. So, well, very happy to help you out, Fausto. And, what was it? Kyle said, you're saving my pre-calc grade. Well, very, very happy to be able to help you out, Kyle. All right, guys, I got 3 problems. That should be pretty much enough. That will be 8 minutes to an hour. So let's go ahead. I'm going to stop off problems unless, let's just go over to my Facebook page just to see, probably nobody did, but just to see if anybody posted a comment over there as far as, well, I'm on Facebook right now, but I want to see if anybody posted any other questions from on that side. Because I did an earlier post on today asking people to go ahead and comment from there. And let's go ahead and see. And my computer does not like running all that extra. Facebook, you slow. Just get to my posts. All right. Sorry, guys. I'll be getting to this stuff. I guess I should probably next time I'll have this popped up so then I can go ahead and take a look at it. Going from there, let's see whatever else the hell. Why are your applications for trig privates? What do you mean, Jesse? What do you mean by applications for trig privates? I'm not sure. I have some older playlists that I have as private, but I'm not sure what you mean as the applications for trig. If you have like a link or like if it's a playlist or a video, I'd be happy to kind of look into it. All right. Yep. No other additional questions from that. So we'll off things. All right. So yeah, just let me know a little bit more what you're referring to on that. No other additional questions. So I'm going to knock these 3 out, guys, and then I will be finished. So All right, so first one, solve. Now that looks like really bad handwriting, so let's change it up here with black. All right, so if I was going to solve this, guys, we have basically x to the fourth minus 7x squared minus 12 equals 0. I'm assuming it was equal 0, otherwise we wouldn't be solving. It wouldn't make sense. We just have to like try to factor it, I guess. So typically when I look into this is, I like to think of this as a quadratic trinomial. So if this is in the form of x squared minus 7x minus 12, and let's just say to factor, let's just say I said factor this. Well, again, factor is the process of rewriting this as a product. So therefore, you're basically looking for, we know that trinomials can be factored into a product of two binomials. We know that x times x is going to give you x squared. And then there's a whole bunch of numbers that multiply to give you 12, or negative 12, right? But there's only one set of numbers that multiply to give you negative 12 that add to give you negative 7. And those numbers is not going to work because, let's see here, negative 12. Oh, jeez. So I'm not going to be able to solve this, at least with the technology that I have here. So this is not becoming factorable because if I need to get this to be a negative 7, let me just double check. Did I have that right on there? Just want to make sure I have this because it's non-factorable as far as I'm seeing. Yeah. All right. That's non-factorable, I see, but okay, that was a playlist, Jesse. I gotcha. Oops. Oh, that's listed as private? That's really weird. That shouldn't be private. I'll go ahead and fix that for you. I'm not sure. That's kind of weird. So yeah, that playlist should not be private. I don't know why that playlist was private. So I can go and fix that after we're done with the live stream. Thank you for letting me know on that. All right. So anyways, we got two numbers that multiply to give you negative 12. So obviously one of them has to be positive and one of them has to be negative. And there are no two numbers that multiply to give you negative 12 that are going to add to give you negative 7. So therefore, this is not factorable. So you can't factor it. So basically, we're kind of stuck here in that thing. So it's not going to be factorable. Basically, what I would recommend doing is actually, you know what? I'll help the student out. So let's go ahead and look at Desmos. So that's what I would do in this case. So I would rewrite this now as a quadratic. Y equals x to the fourth minus 7x squared minus 12. And let's go ahead and see if there's any solutions here. So I'm going to now graph this. And when we're solving, we're basically looking for the x-intercepts, all right? So y equals x raised to the fourth. So even though we couldn't do it algebraically, I'm assuming that you would have a graphing technology with you. X squared minus 12. All right, and we do have two real solutions. They are going to be irrational. And then we have, looks like it's going to be two imaginary solutions. So, I guess we would have to be able to factor this across imaginary and across irrational solutions, which is just going to be a little bit too much for me to kind of continue on from this. So obviously I can look at this by looking at the graph. I can see that there are two real solutions. They are irrational. And then obviously there's going to be two complex. But as far as showing you a step-by-step, that's just going to be a little bit too much for me to be able to handle here on the end from there. I'm trying to think if there's any other system that I want to send you to be able to look at, be able to do. And I'm not thinking of anything else simple that I would solve for you. So either way, I know this is non-factorable. Obviously, if you're just looking for the solutions, I would look into graphing it. But as far as like showing a step-by-step process, if you're not able to graph it, I don't have the time to kind of go through that to expand upon this at this moment. So I'll just have to end it from there, being that the solutions via graphing, so I'll just say by graphing, my solution set is going to be a negative or plus or minus 2.902. Okay, whereas the other two solutions are going to be complex. All right, if I needed to, the next one is to FOIL. So just remember, FOIL is, first, outer, inner, last. And you can see here that these are basically a difference of two squares. And if you remember difference of two squares, a minus b times a plus b, right? So when you have two binomials that are exactly the same, one's the difference between the terms is subtraction, the difference between is addition, that just simplifies to a squared. Actually, let's just work it out. This gets you to a times a, right? And then you do a times b. So this would be a squared, and then this would be plus ab, and this would be minus ab, as the order doesn't really matter, and then it could be minus b squared. So what you notice is the middle terms add to 0, and you're just left with a squared minus b squared. So you notice here that this is the same form. So rather than actually doing FOIL, when you recognize the difference of two squares, you can just square the first two terms and then square the last two terms, which is going to give you a negative 4c squared. So basically I'm just squaring these two, and then I'm squaring these two, because the middle terms are going to add to 0, right? It works every single time. So therefore, that would be our final answer. All right, last one is to find the intercepts. Well, that's going to be y minus 4 is equal to 7 times x minus 6. Okay, so the main important thing, guys, is there's a couple different ways you can do this. But I just like to think of, one thing that's even in pre-calculus comes up a lot. X-intercept is when y is equal to 0. So, and the y-intercept is when x is equal to 0, right? If you look on a graph, where the graph crosses the x-axis, right, y is equal to 0. And wherever the graph crosses the y-axis, the x value is equal to 0, right? So, I mean, that's a common of any graph, of any function. So, what I would just do is just plug 0 in for y and then solve for x. So I apply the derivative property here. So I get negative 4 equals 7x. Let's see, minus 42. And then let's add the 42 over to the other side. And therefore, that's going to be a 38. And then just divide by 7. So x is equal to a 38 over 7. And now for the next problem, do the exact same thing, but now we're just going to plug 0 in for x. So we have y minus 4 is equal to 7 times 0 minus 6. Well, 0 minus 6 is negative 6, so I have y minus 4 equals a negative 42. Add 4, y is equal to a negative 38. So those are your two intercepts. So that is going to be your x-intercept, and that would be the y-intercept. So hopefully that helps you guys out. I had to close down the chat. Oh, I went back up and open there. Awesome. So there you go, ladies and gentlemen. That is the live stream for today or for tonight, whatever it is and wherever you are. But again, just to hopefully you guys got some recap for the law of cosines. And then just to give you guys a heads up, I will be going live again this Thursday. What we'll do is I'll cover the quiz that I gave to my students, covering word problems, law of sines, as well as law of cosine. So we'll plan to do that again, same time on Thursday. And then till then, you guys stay real, and I will see you guys on Thursday.